So this is the third video for the problem 3.9. So here which we're going to talk about a neutral. If you have a ball which is neutral, now this time you cannot just say I'm going to fix that. No, it's not possible. You know, the neutral, which means Q2 plus Q3 has to equal 0, or Q3 equals negative Q2. So because we know that the Q2 just equals negative R divided by A times Q. So in other words, my the neutral case, my Q3 will equals this amount. And from this, you also can calculate forces now between these. When the forces is rather easy, just F. You have a F12, which is the force from Q2, and you also have a force from Q3. These are the same line actually. I just do not need to use vectors, just as far as you understand the direction itself. So you have these contributions, and so that's what you get. The final answer should be Q squared 4 pi epsilon 0, like these. And make sure this F12 is just the Q1 Q2 divided by 4 pi epsilon 0, and distance between these two just essentially A minus B squared. And you do the same thing with the F13, and this will becomes Q3 will be the A 4 pi epsilon 0. You have Q1 here, should be A plus C squared, and just take out the directions. So so that will be that's it. So the final solution will be A minus 1, A minus B squared, and A squared like these. So that's all you need. Okay, so this, my C here is equals 0, so that's why you can see this is just A like that. Okay, so this is the second video, and I hope you got the idea. And finally, I want you to show you that if you have a neutral ball, how large V0 will be. So it's not arbitrary when this time. Did you see here the neutral ball, which is you always have this expression which means like this. If you have neutral balls, so then the Q is just equals this amount. So Q3 just equals this amount. Let me show you what that will be. This will become positive or negative like this. So in other words, my Q3 will be R divided by A times Q equals 4 pi epsilon 0 V0 times R. Okay, so this is the if neutral case. So let me write down neutral. So this will be neutral case. Neutral case, which means Q3, Q2 differs by a negative sign. So this would be Q3, and you have R over A times Q. So then we have cancel these two R's. So my V0 is not arbitrary. You can see should be 4 pi epsilon 0 in the denominator, and you have divided by A and Q0. Or Q, sorry. This is the Q, just Q1. So my potential has to equal this amount in order to the ground will be neutral, or the conducting sphere is neutral. So even though there's no charge, net charge so to speak, but the potential is non-zero in order to make that up.